Okay, good morning, everybody. So today we're going to talk about Section 7.5, Day 1 of the side splitter and mid-segment theorems. So here's an example, or the theorems themselves. So the side splitter theorem is if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So if you look, it says, if we're given that MN and AC are parallel, then you would know that AM over MB and CN over NB also share a proportional relationship. We're going to apply this one in just a couple minutes. If a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and is half as long. So what we're saying here is that if DG is congruent to GE and FH is congruent to EF, we know that DG joins midpoints. We're not saying that both these sides are congruent, we're just saying that this joins the midpoints of the two sides. So what we can do is we know that GH would then be parallel to DF, and we can just state that, hey, GH is going to equal half of DF. So let's get into this idea of the side splitter theorem. It says, what is the value of x in PQR? So P to Q to R, and here is x. All right, we have x right here and x right here. Well, one thing we know is that ST and PR are in fact parallel. That is shown by the little arrows right there. So therefore, we have this proportional relationship of PS over SQ equals RT over TQ. So your best idea here is you see how we are going to add these up. So SQ is 4 plus 12, which gives us 16. So they're saying from here to here is 16. And then TQ is 3 plus 9. So from here, come on, to here is 12. Okay, so now what we need to do is we just need to substitute in these parts. So P to S is x plus 2. S to Q, we found out, is 16. R to T is x. And T to Q is 12. So what we do here is we cross multiply. We're going to cross multiply these two and these two, giving us 12 times x plus 2. And this will be 16 times x. If we continue with this process, we're going to have 12x plus 24 equals 16x. Subtract the 12x from each side. That leaves you with 24 equals 4x. We divide both sides by 4, we get x is equal to 6. So now that we have this, we know that PS here is equal to 8, and we know that TR is equal to 6. So now, the next question lies, what is the value of y? So here's y, here's z. We don't need to worry about z, we just need to worry about this and something else that will help us determine this proportional relationship. Now, looking at this, I can see that y connects here and here. And if I add this up, I have 8 plus 4, which gives me 12. So P to U is 12, but that means U to Q is also 12. And if we look here, we have V to R, which is 3 plus 6, which gives us 9. And Q to V is also 9. So in this case, we can apply the triangle Mid-segment theorem. Okay, and that triangle mid-segment theorem is pretty much telling us that this is half of this. So we would just take y equals 1/2 of PR. So y is 1/2 of 30. So y is equal to 15. Okay, so that one was pretty easy. Z is going to be a little different. Now, this is one of the ways you can do these, or I mean, you can also do what we did before, where you applied the two triangles. So since we've already applied the side splitter theorem, I'm going to show you using the two triangles method, just so you have a comparison. Either way, you would get the same answer. Okay, so now for the value of z, we see that z and st and pr are parallel to each other, so we're going to use the side splitter. Okay, we're going to use side splitter theorem, or you can use the two triangles. So I'm going to show you the two triangles part, so I'm just going to kind of draw this out. So I have this larger triangle, which is PQR. Okay, and I have, now if I added all of PQ, that's going to leave me with 24 on this side. We know PR is 30, and we also know that QR, if we added 9 and 9, that would give us 18. Okay, then we have our smaller triangle, which ends up being S to Q to T. And we have those sides as well. We have S to Q would be 16. We already added that up earlier. We would have T to Q, which would be 12. And then we'd have ST, which is Z. So in this case, I set up the proportional relationship. I'm going to set this up. Again, you can choose, one side is automatically chosen for you. You have to set PR with ST because you're trying to solve for Z. But the rest is kind of up to you. I would do QP or Q with QS or QR with QT. In this case, I'm going to set this up as P to Q over S to Q equals P to R over S to T. So this is going to be set up as 24 over 16 equals 30 over Z. I cross multiply, that leaves me with 24Z equals 16 times 30. This will be 24Z equals 480. Leave me with the end of Z equals 20. Okay, now let's talk about the corollary to the side splitter theorem. If three parallel lines intersect two transversals, then the segments intersected on the transversals are proportional. So in this case, if we look, we have line L is parallel to line M is parallel to line N. And we have these two transversals right here. That means that AB would be proportional to BC and DE would be proportional to EF. So let's apply this in our in our example here. It says a reflecting pool is separated by walkways parallel to Lincoln Street. So here's Lincoln Street, so here's those walkways. And Jefferson Street. So here's Jefferson Street again. These are going to be parallel to that. The city wants to add additional tiling around the pool. How much tiling does X feet represent? So in this case, we're looking at this and we're trying to solve for the rest of this. So the first thing is what's happening here, and we need to kind of get an idea before we get too heavy into this. The question is, what are the transversals? In this case, Walnut Street and Spruce Street are the transversals. So Walnut and Spruce are transversals. Okay, so since those are transversals, we can compute this. So now remember, I have this proportional relationship. So I'm going to have here X over 60. Okay, so this is proportional with this, equals 24. So I'm taking the part that's across from the X over 72, which is a part across from the 60. Cross multiply, we get 72x equals 60 times 24, which is 72x equals 1,440. Divide by 72 on each side. That leaves us with x equals 20. So we need to interpret what's going on here. In this case, we're going to state that x represents 20 feet of tiling. Okay. Now, why don't you guys give this one a shot? So how much tiling does y represent? So here's y. Okay, so why don't you use this portion and solve, and we'll go over that in just a minute. Okay, so looking at this, what I did was I'm going to do y over 72 equals 24 over 60. So we can use what we had before. Now when I cross multiply, that leaves me with 60y equals 1728. That's from multiplying the 24 and the 72. And I'm left with, when I divide, y equals 28.8. So that would be the final answer. Okay, that's it for today. Hop on to Google Classroom to find your homework. If you have any questions, please feel free to message me. And I would prefer a private message through Google Classroom just in case. Okay, it would be a little better. It'll be easier to get than an email right now. Anyway, have a wonderful day, and I will see you guys tomorrow.